Just how we were saying, sound, it passes from layer to layer of air, right, as it propagates. Okay, so if each layer of particles is closer to the last one, like the particles are very close together, what happens, right, is that the energy transfer is very easily done. The neighbor is just next to me. I can easily pass my energy to him. Okay, so that's why, right, when sound kind of likes to travel in very, very closely packed mediums. An example of a very closely packed medium is any kind of solid. Okay, so yeah, because particles in a solid are so close together, sound wave can travel from one layer to the other layer very easily and very quickly. Okay, so that's why that sound travel fastest in solids and then the slowest in gas. Okay, all kinds of solids. So wood, plastic, glass, table, wall. Okay, all these can transfer sound very fast. Okay, as compared to, let's say, through air, which is a gas. Okay, this table here of the approximate speed of sound in the different states of matter, right, is a guide, so that when you're expected to calculate the speed of sound, which you'll be doing a lot in this chapter, you have a rough gauge of whether your answer is correct or not. So if, let's say, the question is talking about sound wave traveling through seawater, I have a sonar, for example, then the calculation, you get something like 1,400 meters per second. Yeah, you're somewhere there. If you get 6,000 meters per second, then something is very wrong with your calculation, right? Okay, just remember the approximate one. This one is more or less common, in a sense, more or less common knowledge, that through air is about 300 to 350 meters per second. Okay, then for liquid is 1,500, solid is 5,000. Okay, so that's how I remember these three. Okay, but again, you don't need to remember this, you'll be good to have. Okay, reflection of sound is called echo. That's it. Echo is just a fancy name of reflection of sound. Okay, reflection of light doesn't have a fancy name. Reflection of sound have. Okay, and that's all an echo is. Sound travel to something else, bounce back. You hear an echo. You hear a reflection. Okay, so yeah, for echo, right, you have a lot of calculation questions. Okay, usually to do with the speed of sound or the distance between two different places. Okay, so I want you to follow this step by step. First, determine the source of the sound, determine the position of the source and the position of the receiver, who is making the sound and who is listening to the sound. Okay, and then determine possible path. All the path will be straight. Okay, even though sound kind of spread out, right, they still go in different paths. So let's say that this is me again, okay, and this is shouting to friend number one and friend number two. Okay, let's say all three of us are in an open field. Sound still travel in a straight line towards friend one, and at the same time it kind of spreads out. Okay, so one of the spread out one also go to friend two. Okay, and at the same time it also goes to all the other places. Okay, each one will still be a straight line even though sound spread out. Okay, so for this one, I determine that the path from me to friend one is like that. Okay, me for friend two is like that. Okay, so determine the path. Okay, and then attribute the time to each path. Okay, so how long did the time travel from me to friend number two? Let's say, all right, and then from there I am able to estimate how far friend two is from me. Okay, let's do two examples, okay, so that we can see what I mean by determine the source of sound and the receiver, and what do I mean by path. Okay, I have a sonar based fish finder. Sonar, don't care, sonar is just something that gives off ultrasound. So I have a ship that's on top of water, and then I got a school of fish, right? Okay, so what will happen, right, is that where is the source? The source is the ship. the ship is making all the sonar, right? So, and then where is the listener? The listener is also the ship. It has the equipment to detect the sonar. Okay, then next, where is the path? The path is from ship source to fish and then go back to the ship again. This is the path. Okay, this whole path, right, took 38.5 milliseconds. Okay, so, and then I have the speed of sound. So the distance sound traveled equals to the speed and time. So 1450 times 38.5 times 10 to the power negative 3. Okay, this will give me 55.825 meters. Okay, but did they ask for the distance sound traveled? They didn't. They asked for how far is the fish from the ship. They are asking for this one. Okay, note that this distance is half of this one. So the distance between the fish and the ship is divided by 2. Approximately 27.9 meters. Okay. Note that a lot of questions that you'll encounter is very, very similar to example 1. But do not blindly divide by 2. Okay, do not blindly divide by 2. I divide by 2 is because the distance traveled by the sound is twice the distance I want to find. Okay, so example 2 is a question where the distance is not just divided by 2. Okay, so first of all, where is the source of sound? Okay, Kelvin fires a firecracker. Hop hears 2 sounds, so Hop is my receiver. Okay, so the sound can go from Kelvin to Hops in 2 ways. 1, directly. 2, it goes to the wall and then bounce back to Hops. Okay, so the sound, he hears 4 seconds and 10 seconds. So this one, the shorter one is the 4-second one, the longer one is the 10-second one. So how far is Kelvin from Hops? Kelvin from Hops is just this distance. And this distance is just nice the exact distance sound move. Okay, so in this case, distance between Kelvin and Hops equals to distance sound traveled equals to 350 times 4. This will give me 1400 meters. And that's it. Okay, no divide by 2. Next, how far is Kelvin away from the wall? So now I want this distance. This one you just need to study carefully. Okay, so the sound took 4 seconds here. It took also 4 seconds here, which means that this part, right, is 6 seconds. This part will be 3 seconds. If it takes 6 seconds to go to and fro, let's say Hops makes a sound and hears an echo, he will hear it 6 seconds later. Okay, and which means that the sound will get the sound 3 seconds. If Kelvin makes a sound, it will take a total of 4 plus 3 to reach the wall. Okay, so in this case, it is just 7, 4 plus 3 times the speed of sound, 2450 meters.